If you want to get from A to B, you better have a path or a road. Even hill walkers can do a lot of harm if there's no path. Water collects in their tracks and people walk around it, causing even more damage. Building paths helps to avoid harming the countryside. Footpaths are quite simple to make. Dig off a level surface and put down some paving stones. Then shore up the sides with rocks and turf.
Oh, it's beauty.
It would take thousands of walkers to wear this away, and you could eventually replace it. But how would you build a road for heavier traffic? One of the first modern road builders to tackle this problem was John Metcalfe, who was born in 1717. He was known as Blind Jack because he lost his sight at the age of 6. But it never seemed to bother him much. In fact, he was a keen sportsman. Jack was once offered a lift from London to Harrogate, which was more than 200 miles. But he turned it down because the roads in those days didn't exactly give you a smooth journey. Jack was convinced it would be easier on foot and spent most of the walk thinking about how to build proper roads. Even though he got lost twice, he still made it to Harrogate in 6 days, 2 days faster than the stagecoach. One of Jack's first big projects was to build a road across the Pennine Hills on very soggy ground. He always decided for himself exactly where his road should go, although no one could figure out how he did it. Once he decided where to put the road, he had trenches dug on either side, with all the earth heaped into the middle. When this was dry, Jack laid bundles of heather, first one way, then the other, to make a strong base. Finally, he covered everything in gravel and stones to make the road surface. The local people turned up expecting to see his road and the traffic sink into the bog. But Blind Jack Metcalfe was too great a thinker to fall for that. Road builders have to know if the ground is strong enough to support the traffic. They also have to be sure that the slopes of cuttings like this one won't collapse onto the road. Cuttings are often used to take roads through hills. After the ground has been dug out to the right shape, the road is built up layer by layer using many different materials. The clay in the ground underneath has to be strong enough to take the weight of all these layers. In a laboratory near the road site, they can do a quick test on the clay that they're building on. The stronger the clay, the more difficult it is to twist the little propeller. The strength of the clay depends on the size of the particles that make it up and on how much water it contains. The strength of building materials often depends on water content. Everybody knows that the perfect sandcastle needs just the right kind of sand. If you want to get scientific about it, you can work out exactly the right water content for sandcastles. He's weighed out 950 grams of dry sand. If he now adds 50 grams of water, Then he's got sand with a water content of exactly 5%. To test the strength, he's going to see how much weight it can take. Making the sand wetter should affect the strength, but by how much? If you've ever tried building a sandcastle, you'll know that sand gets a bit stronger as it gets wetter. But if you make it too wet, it's completely useless. Having found the perfect amount of water to use, he's ready to mix up a decent amount of sand to build with. If you're building a road, you need something for vehicles to move around on while you're building. The capping layer is made from sand and gravel, which are taken from pits near the road site. There are usually bits of stone in it as well. Drainage pipes are laid to take away any water, which would reduce the strength of the capping layer and the clay underneath. The capping layer helps to support the rest of the road and gives a flat surface to move around on. The next layer of the road is concrete. This concrete mix contains two different sizes of gravel. The gravel goes together with sand and cement, a manufactured material which holds everything else together. When all this is mixed with water, it makes a very strong building material. You can make cheaper concrete by using crushed rock instead of gravel and putting in a bit less cement. But it won't be as strong. Road building needs enormous amounts of concrete. Most of the raw material is dug out of nearby pits. It's washed and sorted into sand and different sizes of gravel. The sand and the gravel is then collected in the right proportions and fed into the concrete mixer with cement and water. concrete is still wet when it's laid on the road. A layer of tar on top keeps water in while the concrete sets. This is a chemical reaction. The cement reacts with the water to give the final dry concrete. The weight of every car puts a large force on the road. But particles of sand and gravel in the concrete cause this force to spread out. The pressure on the road is weight divided by area. By the time it reaches the bottom of the concrete layer, the weight is spread over a bigger area. So less pressure is put on the layers underneath. Concrete is incredibly strong in compression. That means you can squeeze it very hard. A small amount of each batch of concrete is tested to make sure it's up to standard. It took 800,000 newtons of force before it failed completely. That's the same as the weight of 10 double-decker buses. One layer of cheaper concrete has already been laid down. They're about to put down another layer of stronger, more expensive concrete, but it has to be reinforced. When a load is put on a layer of concrete, it bends. This squeezes the top half of the layer, but we know concrete can be squeezed very hard. The bottom half is stretched. Concrete is not as strong when it's stretched, so they have to strengthen the bottom half of the layer. Steel reinforcements are placed on top of the previous layer of concrete, and the new layer is poured in. A thin wire marks the thickness that's needed, and powerful pistons keep the whole machine suspended at just the right height. There's one more layer of road to come. Why isn't smooth concrete a good surface to drive on? The surface of a road needs to have good grip, so that vehicles can stop quickly in an emergency. Surface water has to drain away, because it makes the road lose grip. The very top surface of a road is usually asphalt, which contains very tightly packed gravel held together by tar. If you look more closely, you can see that small chips of stone are rolled into the asphalt before it sets. This gives a rough surface, so car tires can get more grip. How would you measure how much grip a road surface has?
Can we borrow your car for a science experiment, please?
Yeah, all right.
The handbrake is on, so the car can't roll anywhere. The force of gravity always points straight down, so it's trying to pull the car down the slope. The friction force is pointing in the opposite direction, so it stops the car from slipping. With a bit more tilt, the force down the slope is increased. When it becomes bigger than the friction force, the car will start to slip.
Stop. What's the first angle?
$26.
The angle of the slope gives a measure of the friction between the road and the car tyres. But the frictional force can be changed with water. Water only made a slight difference. What about a slippier liquid? Oil makes a huge difference to friction. That's why oil on the road spells danger.
Thanks a lot, bye.